Welcome to massive open online course on chemical process intensification. In this module as optimization for process intensification, we will discuss something about optimization and chemical process intensification, and also some algorithm and how to actually get the solution for that we will be discussing in this module 5. And under this module 5, in the first lecture we will discuss something about the stochastic optimization, basic things. So, in this lecture it will be including the definition of an optimization problem for process intensification, and types of optimization problem for the process intensification. Also, special attention to be given to the stochastic optimization, methods for solving problems involved in process intensification in the chemical engineering processing. In the previous module, we have discussed regarding the different scale and stages of that sustainable design, and also what are the different methodology, and for that what are the different computer aided tools are being used for the sustainable design. So, based on that, whenever you are going to design that certain process, that design should be also will be based on the optimization techniques, optimization aspect. So, here that is why we should learn something about that basic of that optimization problem for the process intensification. Now, what is that optimization? Generally, this optimization is a tool for the intensification of chemical engineering process, especially if you consider that maybe this optimization will be that for other type of processes. And based on this optimization tool, your objective is to maximizing or minimizing some function that will be related to some set based on that process condition. And also this optimization will often that represent a range of choices available in a process condition. So, what are the variables to be taken for that analysis of that process, and based on which that design should be further considered, and whatever functions will be considered based on that operating conditions, that functions will allow the comparison of the different choices for determining which might be best for the optimal design of the processes. So, that is why you have to define that function for the that maximizing and minimizing, or minimizing you can say that relative to the set of operating condition. Now, here some examples are given for the optimization problems which is involved in process system engineering, such as that if I consider that there are several stages of that operation. So, in that case process model building stage that we have discussed in the earlier lectures, also different stages and different level of solving that for the design of that sustainable processes. So, in that case that stage are process model building, process design and synthesis, process operations, those are stages. In that case what are the optimization problems are actually coming, that also to be considered. So, in the stage of process model building, you will see the optimization problems will be global and multi objective optimization problems, such as parameter identification in thermodynamic and kinetic analysis of the process, and also what are the phase equilibrium conditions that also to be actually calculated based on this optimization process. And process design and synthesis, in that case again that optimization problem is the global and multi-objective, and in that case you can have an example like heat exchanger network design. In that case you have to choose that optimization problem as a global and multi-objective optimization. And process operation, that is also global and multi-objective optimization problem. In this case scheduling batch plants and managing the supply chains are the examples for this stage of process operations for optimization problems. So, in this case we have to say that traditionally the optimization problems in chemical engineering actually have been handled using a single objective function, and that case the single objective function is generally related to an attribute or you can say that characteristic to be minimized or maximized for the system under analysis. So, this type of optimization problems encouraged the development of novel and powerful numerical strategies. So, that is why the traditional optimization problems may not be useful nowadays, because whenever we are going to design any chemical process based on the process intensification, there are several different objectives simultaneously will come. So, in that case you have to consider all those that different objectives for the design. So, that is why whatever optimization actually techniques earlier was used, that was mainly focused on the solving of the single optimization problem. But for process intensification and nowadays the design of chemical engineering processes must consider that different objectives simultaneously. What are those different objectives to be considered, like what are the energy consumption, what are the environmental impact, and also what are the social impact. Also among others there are various objectives should be considered for this design of chemical engineering process. And in that case you have to compare this multi objective optimization process with the single objective multi. Then you will realize that how process intensification actually will act a role based on this optimization problem. And then after that you have to that implement that chemical engineering process based on that by comparing that earlier and also nowadays that problems solution in the design aspect. So, in earlier stages you will see that it will depend almost exclusively on the value of the that internal rate of return, whereas nowadays this value is used with other indicators in the order to consider the impact on like environmental, social and sustainability aspects. So, that is why whenever you are going to implement that chemical process, that internal rate of return value of course should be based on that environmental, social and sustainability aspects. So, that earlier stage that only a single objective, single that conditions actually are being used for that analysis of that design or optimization process, whereas nowadays it is being used based on that environmental, social and sustainability criteria. Now, considerations of simultaneous effect of environment, social and that sustainability aspects make the chemical process synthesis a more relatively complex problem. And in that case to have and optimal solution, different criteria should be considered simultaneously based on that those effects. So, by considering these three effects of environment, social and sustainability, whenever you are getting that complex phenomena, you may not get that single optimal solution there, maybe a different that multi optimal solution you can expect for that. But to get an optimal solution, that a different criteria should be considered based on those effects. That means, there are several that variables that are effects on the objective functions. So, those objective functions to be considered based on that effects. Now, what are the limitations of that optimization problems? In that case, the chemical processes generally use a multi-objective nature, and also that normally there are several objectives in conflict between them. So, that conflicts restraint to requirements, physical or economical limitations. So, that is why there are some limitations that you have to consider during your optimization problems, how to actually segregate those that conflict of several variables between them, so that you can that several objectives in the conflict between them can be that you can wisely considered by just neglecting that conflict of that multi objective nature of that variables. Optimization methods are generally, in this case, if we talk to that what are the different methods that are available to get this optimization of this chemical engineering process. In that case, available methods are deterministic and stochastic. In that case, both the methods include algorithms with local and global convergence properties for handling one or several objective functions simultaneously. So, first of all, let us consider that how these optimization tools may vary significantly depending on the problem at hand based on the parameters. Now, what are the parameters actually that affect on that optimization tools, like that characteristic feature and the convergence properties, capabilities and limitations. These are the four that parameters that affect on the optimization tools significantly. And also, if we consider that deterministic methods, in that case the method actually search systematically for the optimum value within the prescribed range of the decision variables. So, these deterministic methods will give you the theoretical and computational guarantees to find the optimum solution. And for the deterministic algorithms, an exact knowledge of the behavior of the objective function is required. Otherwise, actually there will be some that information to be missed for that. So, that is why based on that gradient informations, exact knowledge of the behavior of the objective function should be that considered. And so, that is why this deterministic methods are useful for the theoretical and computational methods which will guarantee to find out the optimal solution. Whereas stochastic methods have an outstanding performance and offer several advantages for solving problems involved in process intensification. In this case, that the methods employ a random search and heuristic to find the solution of the optimization problem. So, in this case you will see there are several advantages and disadvantages also will find here, that because that in stochastic methods sometimes you have to search the random variables, and also that some heuristics you have to consider to find the solution of that optimization problem. What are those advantages of that stochastic method? In this case, these methods do not require any assumptions for the problem at hand here. So, these are the advantage, and they are capable of addressing the non-linearity and non-convexity of the objective function as a black box problem, and they are relatively easier to program and implement. And also most of the methods have their extrapolations to multi objective optimization, and also they are proper to that parallelization to efficiency or efficiently handle large scale optimization problems. So, they reduce significantly the optimization time, especially for the problems with different decision variables. So, what are the different types of stochastic methods that you have to know? Several methods actually based on the stochastic considerations are proposed. So, in that case these methods actually solve the single and multi objective optimization problems in process intensification. So, what are those different types of stochastic methods, like simulated annealing, genetic algorithm based, differential evaluation or evolution, and particle swarm optimization, harmony search, and colony optimization, other new or hybrid algorithms are there. So, these are the several stochastic methods which are being used for solving that single and multi objective optimization problems in process intensification. What are the basis of stochastic methods? Actually, these methods are based on the application of exploration and exploitation strategies, which are generally developed from principles of natural phenomena and artificial intelligence. So, this was the basis for that stochastic methods. Now, to get the that numerical performance, you have to converse the behavior of the stochastic optimization methods and which are to be determined by both the intensification and diversification strategies, and it guides and modify the numerical operations to efficiently explore the search space of decision variables in order to find the optimal solutions. So, here very interesting that whenever you are going to find out that numerical performance, you have to consider both the intensification criteria, why this process intensification is being done, on what basis this intensification is done, that several criteria, several aspects, several that change of geometry, either change by geometry or not, either change by that concentration variations, or either you are changing that process intensification based on the that surface properties, or some other that like the reduction of equipment, or you can say that reduction or that suitable using solvent, even suitable materials, even what are the suitability of the environmental impact, positive or negative, all those actually factors to be considered for the performance of that optimization problem. So, in that case you have to sometimes modify that numerical operations based on those that factors, and also you have to search that decision variables among of them, where to find out that optimal solutions based on those that decision variables. So, the decision variables to be found based on that, you may search that decision variables based on that building block phenomena that we have discussed in the previous class. Also there are different phenomena based building blocks, like that mixing characteristics, reaction phenomena, even that separation even that two phase mixing, multi phase mixing, single phase that in a mixing, even geometry, even some dividing rule. So, all those phenomena based building blocks to be considered, and among those that building blocks that you have to search some suitable phenomena based building blocks, and based on which you have to make a set of simultaneous phenomena based building blocks, and those simultaneous phenomena based building blocks you can identify the that decision variables to find out the optimal solution also. So, to determine the numerical performance and the convergence behavior of the stochastic optimization methods, what is that? You have to determine both the intensification and diversification strategies based on that phenomena of the operating variables. Commonly used stochastic methods are generally two categories, like population based methods and point to point methods. In this case, these two categories are commonly used for the classification of these stochastic optimization methods. In the first that classification, it is called population based methods. In this case, generally employ a set of solutions at the end of you can say each iteration. So, you can get the set of solutions at the end of each iteration, whereas point to point methods will provide solution based on the algorithms which are being used only one solution at the end of the each iteration, from which the search will start in the next iteration. So, that is why point to point methods, for that you have to use some algorithm, where your search of that solution will be based on that iteration of the previous part. And hybrid optimization strategies may also been developed by combining two or more meta heuristics to improve reliability and efficiency of traditional stochastic optimization methods. What are the definition of that optimization function? How to define that optimization function? An optimization problem, single or multi objectives, whatever it is that involved in process intensification, which can be defined based on that different operating variables. Now, you have to use this optimization problems as optimize of that, what is that, f 1 x and f 2 x dot 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 f k x, where x, what is that? X is the vector of n number of decision variables with lower bound and upper bound. And these functions that if here this optimization function based on that decision variables, and k is the number of objective functions, how many objective functions you are making, and also what are the limits of that the decision variables should be lower bound to the upper bound, and this x should be a set of like this x 1, x 2, x 3 and dot 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 n. So, this is way how to actually that optimization function can be defined. The objective functions are subject to certain that constraints. So, what are those constraints? Maybe different type of constraints will be there. Sometimes m inequality constraints, same number of inequality constraints will be there. Maybe g I g I as a function of x to be represented, and which should be greater than equals to 0, where I here as 1 to dot 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 m, like this m number of inequality constraints, and p is equality constraints. There some equality constraints should be also considered as a constraint there. In that case, it should be represented by h I x, that should be equal to 0, and in this case p number of equality constraints to be there. So, the objective is to determine from among the set f of all vectors In this case, like this g I and h I for the function of those vectors variables, and the particular set of values here in this case x 1 star, x 2 star, x n star, that will yield the optimum values of all the objective functions. So, the solutions will be like this here x 1 star and x 2 star and x n star for this objective function for the maximization or minimization based on this that constraints of m number of that inequality constraints and p number of equality constraints. And the objective functions, if I involved in the optimization of chemical processes are indicators of their characteristics, operation and performance. These three important indicators are very important to consider during your definition of that objective function, and they can be related to the different metrics like the process effectiveness, economic indicators, environmental impact, even environmental assessment, life cycle assessment, safety and reliability, control properties and others attributes, characteristics of interest that is to be improved, and also the analysis and also including any combination of them also to be considered for the optimization. And for the case of process model building, these objective functions can be related to different again factors like thermodynamic factors, thermodynamic calculations or parameter that will that identify the problems. So, that is why for the case of the process model building, these objective functions can be related to the thermodynamic calculations or parameter indication problems. If the problem associated with only one objective to be optimized, in that case it can be solved as a single optimization problem, and this optimization can be classified in subfields depending on that the characteristics of the objective function, types of decision variables and the constraints. Now, types of decision variables may be based on that suitability of that phenomena based decision variables can be taken there, and also that type of the constraints, what type of constraints that you are consider that also to be considered for that optimization. In this regard, the target is to identify the set of values for the decision variables that provides the that maximum or minimum value as a global of the objective function that are being used. If two or more objective functions to be considered, in that case the problem will be handled as a multi-objective optimization problem. In this case, the objectives are in conflict between them, thereby a simple solution is not here desirable, or in some cases when it is not feasible. For this kind of problems, a set of optimal solutions that represents the best trade-off between these objectives in the goal, and in that case it is not actually considered that single solution to be obtained here. So, instead of single solution, a set of optimal solutions will be obtained based on that kind of problems. So, whether it is multi-objective optimization or not, that should be of course there. So, for multi-objective optimization, in that case you will have a set of optimal solution instead of the single solution. Whereas, in the single objective functions there may be that only single solutions you can expect also. So, in the case of multi-objective functions, the objectives are in conflict between them, thereby simple solution is not desirable, or in some cases even not feasible also, because in this case you are considering several decision variables based on that environment, social and also other consideration. So, the set of optimal designs can be achieved by means of Pareto front. What is that Pareto front? This is generally a set of optimal non dominated solutions, and the Pareto front allows having not just one optimal solution, but a set of optimal solutions that represents the best compromises between the objectives in consideration. So, Pareto front should be considered here. What is that Pareto front? A Pareto front is defined as a vector or decision variables x star which belong to that objective function. So, it is called a Pareto optimal if there does not exist another x which is belong to objective function, such as a phi x is less than equals to a phi x star. Here as shown in the slide, that here in this case that Pareto function, that is decision variables of x star for that function should be greater than equals to a phi x, that is function of x which is exist or not exist another x function. So, for all I 1, 2 and k, and also a phi x should be less than or equal to a phi x star for at least one j. And this x star is Pareto optimal if there is no feasible vector of the decision variables x belongs to f function. The A set of Pareto optimal is called as Pareto front. So, Pareto front is nothing but the set of Pareto optimal solution. Traditionally, the objective functions involved in the intensification of chemical engineering processes are highly nonlinear, multivariable and potentially non-convex. So, this is to be considered in this case in this case of course, whatever solutions you will get may be based on that nonlinear function, multivariable or potentially non-convexive functions. And the complexity and the difficulty of this solving of these optimization problems will may be there. In this case it will include the analysis of their solutions are likely to increase with the number of objective functions that are being considered. So, in this case you have to wisely select that decision variables to get that optimal solution there, especially for that multivariable objective functions. And the optimization variables which are being used for that intensification of the chemical processes generally are degrees of freedom related to the operation and also configuration and physical characteristics of the system under analysis. And these variables can be that continuous or discrete also. So, these are the that different optimization techniques that we have discussed in this lecture, and we are getting different types of that optimization technique, deterministic and also you can say that stochastic optimization techniques. There are several that advantages of the stochastic optimization techniques relative to the deterministic techniques. Generally these stochastic techniques are being used for that optimization of these chemical processes are being that in process intensification of this chemical engineering process. So, in that case sometimes you will consider that these stochastic methods some decision variables to be considered and also different aspects of social, economical and also that other different conditions to be considered for your process optimization. So, you have to define that objective functions there, whether these objective functions are multi objectives or single objective. In that case, single objective case you may get the single solution, but it will be easier, but whereas multi objective functions, in that case this solution will be very complex, and also in that case the constraints of that multi objective variables will be more. So, in that case wisely you have to select that decision variables based on that other criteria of the processes. Now, whenever you are going to intensify the process, then based on that intensification, what are the different that variables that you are actually optimizing, and because process intensification phenomena will actually be based on that different criteria. It may be based on the surface properties, may be based on the mixing characteristics, it may be based on that geometry of the system, it may be the number of the equipments, it may be that flow patterns. So, all those hydrodynamics characteristics, even reaction kinetics also to be considered for the that constraints. So, not only these technical parts you have to consider, even some other that impact of the environmental impact should be also considered in that case. So, there that configurations, analysis of the degrees of freedom, physical characteristics of the systems and its analysis of course to be done beforehand, and also to get that optimization problems based on these characteristics of the different variables, you may get that multiple solutions, multiple optimal solutions. So, that is why optimal Pareto front will be obtained, that is a set of different nonlinear solutions, or you can say that different optimal solutions, set of different optimal solutions to be obtained there. So, those optimal solutions may be obtained based on the variables which are maybe sometimes continuous, sometimes discrete. So, here we have actually gone through some that basic of that optimization techniques, and for this optimization techniques you need some algorithms, computer based algorithms, also some tools also sometimes are being used, that already we have discussed in the previous lecture, that what are the different types of computer aided tools are being used for the process design, and that process design based on this optimization problem. So, there are several tools also are available and algorithms also are available there. So, we will discuss in the next lecture what are the different types of algorithms there for this optimization techniques. So, I would suggest to read further about this optimization techniques, this textbook as well as some other reference also you can follow for this. So, I think we have discussed something about that optimization, how it can be used and what are the objective functions, all these things. So, next lecture we will discuss about the algorithm of this optimization techniques. So, thank you for this lecture.